Hi, my name is Costa Resistor. I'm going to show you how to solve a series parallel DC circuit problem. So let's look at the problem. Two resistors of 36 ohm and 18 ohm are connected in parallel. If the combination is connected in series with an 18-volt power supply and a 6 ohm resistor, what is the current flowing through the 36 ohm resistor and what is the total current flowing in the mains? First of all, let's draw the circuit. So we have the resistors. Okay, this is R1, 6 ohms, R2, 18 ohms, and R3, 36 ohms. We have the power supply, okay, 18 volts, and drawing the current in circuit, we are going to have in here I total in the mains. It junction B, it will split in two currents, okay, IR3 and one flowing up IR2. Okay, so at junction A, the currents will join again for the main current in here, I total. So looking at the circuit, you'll see that those two resistors R2 and R3 impart the same potential difference between A and B. So in this case, they are in parallel. So R2 and R3 are in parallel. Their equivalent resistance will be, okay, we are going to have in here 18 times 36 over 18 plus 36, which is 54. Simplifying, we are going to have in here 36 over 3. So the equivalent resistance is just 12 ohms. Simplifying the circuit, we are going to have the new circuit looking like this one. So the resistor in main, 6 ohms, and this one in here is the equivalent resistor, okay, 12 ohms. Doing again the currents, we look at the only current flowing to the circuit is just the total current. This is the EMF, the source voltage, and in here we are going to have the 18 volts. Total resistance in circuit will be R total is equal to R equivalent plus 1, and we're going to have 18 ohms. Current in circuit will be, total will be the source voltage over total resistance. We are going to have 18 over 18, 1 amp. So one solution in here will be 1 amp for the total current in circuit. How do we find the currents flowing through these two resistors in parallel? Looking at the potential A and B, having in here, let's say that B is the potential at B is the same as the potential at ground. Potential at B is the same as potential at ground. Now we have to find out the potential at A. How do we find the potential at A? Just simply through the Ohm's law. So potential at A is defined as potential at source, let's say source in here Vs, minus the voltage drop across the this main resistor, voltage drop across R1. So if we know the voltage drop across R1, applying Ohm's law, and the potential source, we can determine the potential A. So therefore, we are going to have 18 source voltage minus voltage across R1 is current flowing through R1 times R1. So we are going to have 1 amp times resistance, which is 6, and 18 minus this one will be 12 volts. Therefore, VA is equal to 12 volts, and VA minus VG will be 12 volts again. So the voltage drop across these two resistors is the same and is equal to 12 volts. Current flowing through R3 will be nothing else than the voltage across it, all right, 3 over its resistance. We are going to have 12 over 36 and gives us 0.33 amps. So we are going to have in here a value of 0.33 amps. How do we verify? So let's calculate the current flowing through R2. So VR2 over R2, and we are going to have 12 over 18, and this one is 0.667 amps. Look at the values. IR2 plus IR3 is nothing else than equal to I total is 1 amp. So our calculation is correct. Therefore, the currents flowing to the mains 1 amp, and the current flowing to the resistor, the third resistor, is 0.333 amps. This is